Another thing to show you all, I don't know if any of you know, but some of you that fix engines will know what this is. This specific part is from a Perkins 4108, 107, pretty sure it's 108. It's an oil pump. Now the shape and geometry of this particular pump is kind of moot, it's just the Perkins design for it, but how it functions inside is very, very common to a lot of engines, and how oil is pressurized around the system. It's very important to understand the difference between flow and pressure. The pump will create flow, it will not create pressure. Resistance creates pressure. The pump is trying to pump against something. So for example, as the engine rotates this, because it's mechanically driven, positive drive, always spinning with the engine because it's an internal combustion engine. This is one of these you pick up, I forget which way round it is at the minute, but one of these you pick up. So at the bottom of this will be your oil sump full of oil, pulled in there and then pushed up into all the various working parts of the engine. And as it's going into different components, so for example, the oil waves will be probably about the same diameter as a biro pen. And it'll go up into, say, something like a journal, which is on your crankshaft, and you have bearings, and they're like old engines like these have white metal bearing shells. And there's a very specific amount of clearance or gap between the bearing and the contact surface of the working part as it's designed to move. That small gap is not enough to push the oil out really quickly, but enough to create pressure to make a film so it can run. That will give you resistance. Resistance means the pump will then start generating pressure. How do you control pressure? Because if you get too much pressure, you could crack a block, you could pop a core plug. There are oil core plugs, don't confuse that with water core plugs, or something else. You need a pressure relief valve. Now Perkins put their pressure relief valve on the pump itself. A lot of engines do that. BMC, for example, the pressure relief valve is actually in the block at the back on the left hand side, if I remember correctly. It's actually a little plug you undo and you pull out the little valve. I'll show you the valve, show you the pressure relief valve in a sec. But typically the way they used to work is it's a spring, special spring tension, and as the oil builds up, in actual fact, what I've got right here, this is a pressure relief valve from a PRM gearbox. It's exactly the same principle. That spring is a specific type of tension. So as you squish it, it creates an amount of force. There's a shim there to get the correct amount of forces. It's very, very similar. I'll pull this one out in a sec. They're slightly different shapes, but generally all you've got is a plunger. So if you can imagine, that's being pushed against a hole, and as the oil comes up against it, the pressure builds and overcomes the force of the spring, and it can bypass, and that gives you an amount of pressure desired. Typically on a BMC or a Perkins, around about 60 psi, and they can drop down to low when the oil gets warm, so it can vary a bit. So you need to manage pressure. If you've got too low a pressure, that's not going to do any good. The engine's not going to be lubricated, and it will die very, very quickly, and I mean within seconds. So how does this work? Well, there's different types of pump, there's different types of method of working, but I will quickly whip it apart and show you how it works. I've already undone the nuts here. This is your base plate. As I say, different engines have a slightly different geometry or shape, but basically this base plate has two ports, one for in and one for out. Very, very simple. Here's your workings inside. Now you can see the little triangle driving membrane, and then you've got the actual outer diameter, which is what creates works with it to create forces. I can't remember which way around it goes, but anyway, as you spin it, you see the nice little action in there. So the veins are starting to compress. So obviously, as the oil's drawn up into one side of the pump, it's being forced into that little gap. It's got nowhere else to go. You cannot compress liquids. It is not possible. So if you compress a liquid, it's got to go somewhere. So obviously, this spinning really quickly, you're going to create a large flow. So you can push oil around the engine, and as this engine is going to be ticking over around about 800 RPM, that's quite a lot. It's going to be generating a good flow of oil all around the engine. And then as you get resistance, the pressure builds, then the pressure relief valve will take over the job. So for example, this bit comes out. Inside here, I don't know if you can actually see it or not, it's just a chamber. Nothing else to it really. It's just a dead end. It's a blind hole, you might call it. All it is the shaft spinning in this part, and that'll be lubricated because it's going to be covered in oil. So with this particular design, that's a very close fit. And then the workshop manual will tell you how much clearance you're supposed to have. So if the pump's really, really old and worn out, then it'll be damaged, and therefore you want to replace the parts in it or replace the whole unit itself. Now looking inside, I don't know if you can see it, it isn't too bad. I've seen worse. but this was changed for good measure because it's part of a rebuild. So when it comes to doing rebuild, sometimes it's best to just do certain things and not take a chance. Now, as I say, as this is spinning, what you're getting, hopefully the light's good enough in here, it's fantastic action. It's just so much fun. You know, actually machining this is just the level of precision you have to have in order for the parts to flow smoothly. Such a cool design. Yeah. Now, PRN gearbox has a different type of oil pump. In fact, I can actually show you the oil pump off this PRM because it's actually behind the camera here. So you can look at my chest whilst I'm showing you. So this is the back of a pump. Bit of dust on it, but that's about getting rebuilt at some point. 2 gears. Now there will be a chamber around the outside. It's one side in and one side out. Not sure which way around it is, but it can change on these gearboxes because they're different. Now you would think that the same action on here as the other pump from the Perkins. It's not. Oil is not pushed in between these gears. It's actually dragged around the outside. I don't know if I've got the actual chamber there. I can't show you. It'd be nice if I could split that quickly, but see this diameter here? This is the surrounding chamber that will fit over these gears. Yeah, little needle bearings in the end to support the shafts. Oil is dragged around the outer diameters. And as it's dragged round, it's pulled. It'll be pulled. So from one point, pulled around, dropped into another point, or pulled from one point, dropped into the other point there. So that's how that gearbox oil pump works. But let's whip back to the Perkins because that's the one I've got out and that's what we're talking about. So 2 different types. So that's a rotating oil pump basically. There are cycloidal, effectively. Cycloidal, lovely word, probably chewing it up, but hey, that's me. Now, the BMC has more vanes, don't know why, that's just how they designed it, probably for more efficiency, higher rate of oil flow, lots of different reasons for doing so. But look at that machine, it is lovely. That's a fine clearance of how that's going. And a slight sidetrack, this is very similar to how a rotary engine without pistons. I won't go into that video right now because that's a bit more complicated, but if you can imagine, you'd have ignition of the fuel here, that would force the triangle piece down, then the next one's getting set up, bang, it's coming round, taking in fuel, it's compressing fuel there, it's compression, combustion. But this is not an engine, this is an oil pump. So basically what's happening here is oil's been drawn up, it's been trapped in this little volume here, it's forcing it round, and just as it's forcing it round, it's being forced out the other side of the pump. Let's have a look at the pressure relief valve. I've actually started taking a pin out, so if it goes boing, that'd be why. Right, well, it won't actually boing at me. Will it just drop out? Or do I have to give it a tap? Oh, there we go. So there we go. There's your port in there. There's your spring. There's your plunger. That creates a little seal at the end. And there's a little cap at the end just to protect it from the pin. So that's how it will go in there like this. And as oil's being pushed against that part there, it creates that resistance, and that resistance helps regulate its maximum amount of pressure it can generate. You could pick your finger at that and say that's getting old. If you're getting too low a pressure, there's no damage anywhere else. So yeah, you can see in there, it's probably not the best light, but there's 3 drillings. So you've got 1, 2 for holding things in, and then you've got the actual functioning part there. And just down this side here, there's your output there. So this will be your output, this will be input. So oil will come in here, it's drawn up by vacuum, and then the pressure would push it up, it'd be squashed around by the pump and pushed down inside there. As it comes down and working to all the parts, once that's all been charged with fresh oil, the pressure would generate backwards, back down the line, because there's various resistance points. So in order to stop the engine from overloading its oil pressure, the valve will go and dump. It will just dump oil out the sides into the bottom of the sump where the oil is. How cool is that? I love stuff like this. Always tickles me, just the amount of work that goes into making a part. Unfortunately now, we don't make a lot of this stuff in England anymore because somebody decided it wasn't good for their business model. Woe is me, eh? Woe is me. there you go. Just have a recap. That lovely working there, beautiful componentry. Just the amount of machining goes in that, and the metallurgy of this metal would be of a specific type that's hardened, and it would resist wear. And obviously that's going to be the most lubricated part in the whole engine because it is the oil pump, ironically. So a good quality oil is really important. This is one of my bugbears with people that buy cheap oils. Oil is oil, it's a thick liquid, it will lubricate and it will do its job. But the additive package is really important. Without the additive package, the different metals and different materials in your engine aren't being protected. Not just metals, you've also got seals and soft neoprene parts. So for example, back to the PRM gearbox, just on this control valve, you've got rubber seal here. Now one of the biggest pitfalls of PRMs is the oil seals go brittle and oil gets passed because it's no longer squishy and stopping the oil. It's because the oil they've used is cheap and it's crap. And what's happening is the oil is actually attacking all the critical parts in the machine, whatever machine that might be. And good quality oil package, good quality oil will have a decent additive package, and that will help make those parts supple and soft again. And it's worth, the one thing I would say you never ever skimp on is oil. You can get away with patent parts and stuff, but when it comes to your componentry in your engines, these parts need to be lubricated properly. Give the engine the good stuff. That's my advice. But yeah, oil pumps, damn cool stuff, man. Now, I was going to use this and turn it into a pump for something, but I don't know what. I'm just dreaming now. Right, hope you enjoyed that. See you later. Bye bye.